Have you ever wondered how your body builds muscle? How does your body transform lifting weights into bigger muscles? If you haven't already, go ahead and smash that like button and hit subscribe for more of our content. Welcome to the Active Wave. Today we're going to embark on a journey into the realm of muscle hypertrophy. This term might sound technical, but it's simply the scientific way of describing muscle growth, a goal shared by athletes, bodybuilders, and fitness enthusiasts alike. For athletes, increased muscle mass can translate into enhanced performance and strength. In bodybuilding, it's about both the quantity and the quality of muscle development. And for those into fitness or for personal health, it's a path to a well-toned and strong body. But how does muscle hypertrophy begin, especially for those that are just starting in their fitness journey? Initially, it's actually not all about the muscle. In fact, the first gains are largely due to neural adaptations. This means that your nervous system becomes more efficient at activating your muscles. As you lift weights, your body learns to engage more muscle fibers and to do so more effectively. This initial neural learning phase is a critical foundation for muscle growth that will follow. In this video, we're going to explore how these early adaptations set the stage for the actual increase in muscle size, which is really a fascinating process involving everything from cellular changes to hormonal responses. So stay tuned as we unravel the science behind building stronger, larger muscles. In the world of muscle growth, not all hypertrophy is created equal. There are two primary types, contractile hypertrophy and sarcoplasmic hypertrophy. Contractile hypertrophy is about the increase in the size of the muscle's contractile components. We're talking about things like actin and myosin. So it makes muscles stronger and more powerful. On the other hand, sarcoplasmic hypertrophy involves an increase in the muscle's sarcoplasm. This is the fluid and non-contractile components within the muscle cell. This type of hypertrophy enhances the muscle size and endurance. There's also muscle hyperplasia, which is a hot topic right now of debate among scientists. Hyperplasia, unlike hypertrophy, refers to an increase in the actual number of muscle fibers. While it's a well-documented phenomenon in certain animals, its existence in humans is still a subject of scientific inquiry. Some believe that under specific conditions, such as extreme mechanical loading, human muscle might also experience hyperplasia. However, the majority of muscle growth in humans is attributed to hypertrophy, particularly to the two types that we just discussed. Muscle growth is a complex process initiated by three key mechanisms: mechanical tension, muscle damage, and metabolic stress. Let's start with mechanical tension. It's the primary driver of contractile hypertrophy and occurs when muscles are subjected to weights or resistance they're unaccustomed to. This tension, especially during heavy lifting, signals the body to strengthen and enlarge the muscle fibers. Next up is muscle damage. You know that soreness you feel after a tough workout? That's a sign of microscopic tears in your muscle fibers. This damage isn't harmful. In fact, it's really essential for muscle growth. It triggers the body's repair process, which not only repairs the damage, but also enhances the size and strength of muscles. Lastly, metabolic stress plays a crucial role in sarcoplasmic hypertrophy. When you engage in high rep, lower weight exercise, it causes a buildup of metabolites like lactate in your muscles. This buildup is associated with that burning sensation that you get and is a signal for the body to adapt by increasing muscle size and endurance. In the journey of muscle building, resistance training, metabolic stress, and muscle adaptation form a triad of muscle hypertrophy. Resistance training through lifting weights or body weight exercises provides the mechanical stress necessary for muscle growth. Different training methodologies, such as heavy lifting for fewer reps or lighter weights for higher reps, impact hypertrophy differently. Heavy lifting primarily contributes to contractile hypertrophy, enhancing muscle strength and power. Conversely, high repetition training, while inducing less mechanical tension, leads to an increase in metabolic stress. This stress, characterized by the accumulation of the metabolites we just talked about, contributes to sarcoplasmic hypertrophy, enhancing muscle size and endurance. So the method of training that you choose significantly influences the type of hypertrophy that you will experience, with each approach offering unique benefits to muscle growth and overall physique. From here, we're going to get pretty sciencey, so if that bores you, go ahead and skip to the end of the video. Satellite cells are vital for muscle repair and growth. These cells, located on the periphery of muscle fibers, spring into action following muscle damage. During resistance training, when those micro tears occur in the muscle fibers, these cells are activated. They begin to proliferate or multiply and then fuse either to existing damaged muscle fibers or to each other. This fusion process is critical for muscle repair and hypertrophy. By donating their nuclei to muscle fibers, satellite cells enable an increase in muscle protein synthesis. This is a key part of how muscles not only repair and recover post-exercise, but also how they grow in size and strength over time, adapting to the increased demands of resistance training. Muscle hypertrophy is deeply rooted in molecular biology, with pathways such as AKT, mTOR, MAPK, and calcium-dependent pathways playing pivotal roles. The AKT-mTOR pathway, where AKT stands for protein kinase B, and mTOR stands for mammalian target of rapamycin. Not saying those again. But it's a key regulator in muscle growth. It's the command center that responds to exercise stimuli and enhances muscle protein synthesis. The MAPK pathway, or mitogen activated protein kinase pathway, acts as a bridge linking the external stresses of exercise to the internal adaptation of muscle cells. Lastly, calcium-dependent pathways, influenced by fluctuations in calcium levels during exercise, further regulate hypertrophy. These intricate pathways form a complex network, orchestrating the muscle's response to exercise, translating cellular changes into visible muscle growth. Hormones and cytokines significantly influence muscle anabolism. Insulin, like growth factor 1 or IGF-1, plays a crucial role in muscle growth and repair. It stimulates protein synthesis and it promotes the activation and differentiation of satellite cells. Testosterone, which is a well-known anabolic hormone, enhances protein synthesis and inhibits protein breakdown, which promotes muscle growth and strength. Growth hormone also contributes significantly, especially in tissue repair and regeneration. Meanwhile, cytokines, which are small proteins released by cells, have a vital role in muscle anabolism. They regulate inflammation and immune responses, and some, like interleukins, are known to support muscle growth and repair. As we conclude our exploration into the world of muscle hypertrophy, let's recap just a little bit what we've gone over. We've seen how muscle growth is not just a matter of lifting weights, but a symphony of intricate physiological processes. From the initial spark of mechanical tension, muscle damage, and metabolic stress, to the complex role of satellite cells, molecular pathways, and hormonal influences, each aspect contributes to the grand goal of building stronger, larger muscles. Understanding these dynamics can empower your training and nutrition strategies, turning each workout and meal into a step towards your fitness goals. Thanks for watching our video, and stay tuned to the Active Way for more insights into your health and fitness journey.